So once the radical signs are removed, if the resulting polynomial is quadratic but not factorable, then use the quadratic formula to solve for the variable. So let's say we had 0 is equal to x squared minus 8x plus 1. Our coefficient of x squared is 1. So we're thinking, okay, maybe we can factor. But then our c is 1. So the only factors of 1 are 1 times 1, which makes finding factors that have a sum of -8 impossible. So although the coefficient of x squared here is 1, this term cannot be factored, so you would use the quadratic formula to solve for x. This is another example of a polynomial that you would use the quadratic formula with to solve for x. So we have 0 on one side, as always. 0 is equal to 2x squared plus 3x minus 7. We can't remove the 2 from each term, so we're left with this expression, 2x squared plus 3x minus 7. So you would plug 2, 3, and -7 into the quadratic formula, which is this. You want to memorize this. X is equal to -b plus or minus the square root of b squared minus 4 times a times c divided by 2a. Write this down and just have it beside you handy so that you can use it at the end of each of these questions coming up. And we're going to plug in a, b, and c into this formula to solve for the variable x. So back to the polynomial we had a second ago. 0 is equal to x squared minus 8x plus 1. A is the coefficient of x squared. When there's nothing there, it's 1. 1 times x squared is x squared. So when it's not shown, the coefficient is 1. B is the coefficient of x, so it's -8. And c is +1. So we plug each of these into their respective places in the quadratic formula. So 1 goes here and here. -8 goes here and here. And c goes here, leaving us with x is equal to -b, which is negative times -8, plus or minus the square root of b squared, so that's -8 squared, minus 4 times a, which is 1, times c, which is 1, over 2 times a, which is 1. So for step 1, you plug a, b, and c into the quadratic formula, and then step 2, you solve for x. So you evaluate this expression. So here we have -1 times -8, which is +8, over 2 times 1, which is 2, plus or minus b squared, which is -8 squared, which is 64, minus 4 times 1 times 1, which is 4. 64 minus 4 is 60. We can simplify this further. Radical 60 is equal to radical 4 times radical 15. And we want to separate radical 60 into these factors because the square root of 4 is equal to 2. So we can negate the 2 in the numerator with the 2 in the denominator. So that leaves us with 8 over 2, which is 4. 4 plus or minus the square root of 15. So we were able to solve for x by plugging the coefficient of x squared, the coefficient of x, and our constant c into the quadratic formula. And then we solve for two values of x. 4 plus the square root of 15 and 4 minus the square root of 15. And then we would check this answer by plugging it into the original equation like we did for the other methods. That is how you utilize the quadratic formula in relation to radical equations. You remove the radical signs, you create the polynomial, and if the polynomial cannot be factored, you plug the respective values into the quadratic formula to solve for x. And then you can check the answers the way you normally would by plugging them into the original equation. So let's wrap this video up by having you complete 2 practice questions. Solve for x and check the answers. Question number 1. The square root of 6x plus 4 minus 2x is equal to 0. Question number 2. The square root of 10 minus x squared minus 2 is equal to x. Pause the video, answer these questions, and then press play when you are ready to begin. Question number 1. The square root of 6x plus 4 minus 2x is equal to 0. So we always want to isolate the first radical. So step 1, add 2x to both sides, leaving you with just the radical, the square root of 6x plus 4 on the left side, and 0 plus 2x leaves you with just 2x on the right side. Now we want to remove this radical sign. So we want to raise both sides of the equation to a power of 2, leaving you with just 6x plus 4 on the left side and 2x squared on the right side, which would give you 4x squared. Now that the radical sign is removed, we want all of these terms on one side of the equation. So step 3, subtract 6x from both sides, and step 4, subtract 4 from both sides. This way we get 0 on one side, which we always want, is equal to 4x squared minus 6x minus 4. So now we have our polynomial. 0 is equal to 4x squared minus 6x minus 4. So we want to plug a, b, and c into the quadratic formula. So that's step 5. So a is the coefficient of x squared, so that's 4. B is the coefficient of x, so that would be negative 6. And c is the constant without the variable, which would be negative 4. So we plug a, b, and c into the quadratic formula, and that would give us x is equal to negative 1 times negative 6 plus or minus the square root of negative 6 squared minus 4 times negative 4 over 2 times 4. So now we want to solve for x by evaluating this expression. Negative 1 times negative 6 is positive 6, plus or minus negative 6 squared is 36, 4 times 4 is 16, negative 16 times negative 4 is positive 64. So then 36 plus 64 is equal to 100. We break this up into two fractions, 6 over 8 plus or minus the square root of 100 over 8. We can evaluate this further. The square root of 100 is equal to 10. So we see x is equal to 6/8 minus 10 over 8. So that would be negative 4 over 8. And x also equals 6/8 plus 10 over 8, and that would equal 16 over 8. So negative 4 over 8 is negative 1/2, and 16 over 8 is positive 2. So we see x is equal to negative 1/2 and positive 2. So now that we've solved for x, step 7, check the answers by plugging each number into the original equation. The original equation was the square root of 6x plus 4 minus 2x is equal to 0. When we plug in negative 1/2 for x, we get 6 times negative 1/2, which would be negative 3. Negative 3 plus 4 is positive 1. Negative 2 times negative 1/2 is positive 1. So that's how we get this. The square root of 1 is 1. So when we plug in x is equal to negative 1/2, we get 1 plus 1, which is 2. And that does not equal 0. So x does not equal negative 1/2. This is not a valid answer. So we want to check the other answer we got, which was positive 2. 6 times 2 is 12. 12 plus 4 is 16. Negative 2 times 2 is negative 4. The square root of 16 is 4. So we wind up with 4 minus 4, which is 0. And since 0 is equal to 0, left is equal to the right, that shows that x does equal 2. So the answer to question number 1 is x is equal to 2. Now let's have a look at the second practice question. The square root of 10 minus x squared minus 2 is equal to x. Step 1, add 2 to both sides, leaving you with the square root of 10 minus x squared is equal to x plus 2. Step 2, raise both sides to a power of 2, leaving you with 10 minus x squared on the left side and x plus 2 squared on the right side. So step 3, we are going to use the FOIL method to expand this expression, x plus 2 squared. So x plus 2 times x plus 2. X times x gives us x squared. X times 2 gives us 2x. 2 times x is 2x. 2x plus 2x is 4x. And then 2 times 2 is positive 4. So once we remove the radical and expand our expression, we are left with 10 minus x squared is equal to x squared plus 4x plus 4. We want to have 0 on one side, so we're going to subtract 10 and add x squared to both sides. So those are step 4 and step 5. Add x squared to both sides and subtract 10 from both sides, leaving us with 0 on the left side is equal to x squared plus x squared, which is 2x squared, plus 4x, and then 4 minus 10 is negative 6. So the polynomial we have is 0 is equal to 2x squared plus 4x minus 6. Now this 2 can be extracted from each term, but let's say that you don't recognize that. So we're going to continue with the original plan of using the quadratic formula. So step 6, plug A, which is 2, B, which is positive 4, and C, which is negative 6, into the quadratic formula. And then step 7, solve for x. So negative b is negative 1 times 4, plus or minus the square root of b squared, which is 4 squared, minus 4ac, which is 4 times 2 times negative 6, over 2a, which is 2 times 2. So that is how we wind up with this. Negative b squared minus 4 times a times c over 2 times a. And then we can solve for x by evaluating this further. Negative 1 times 4 is negative 4. 2 times 2 is 4. Plus or minus the square root of 4 squared, which is 16. Negative 4 times 2 is negative 8. Negative 8 times negative 6 is positive 48. 16 plus 48 is 64. So we wind up with negative 4 over 4. Plus or minus the square root of 64 over 4. The denominator goes here and here. We can evaluate this term further. The square root of 64 is 8. So we see x is equal to negative 4 over 4 minus 8 over 4. Negative 4 minus 8 would be negative 12 over 4. And then negative 4 over 4 plus 8 gives you positive 4. Negative 4 plus 8, positive 4. So x is equal to negative 12 over 4, which is negative 3, and 4 over 4, which is positive 1. So we get x is equal to negative 3 and positive 1. And then step 8, check the answers by plugging each number into the original equation. The square root of 10 minus x squared minus 2 is equal to x. Plug in negative 3 in both places where you see x. 10 minus negative 3 squared is 10 minus 9. Negative 3 squared is positive 9. 10 minus 9 is positive 1. The square root of 1 is 1. 1 minus 2 is negative 1. And since -1 does not equal -3, then that means that x does not equal -3. This is not a valid answer. Now let's check +1. 10 minus 1 squared is 10 minus 1, which is 9. The square root of 9 is 3. 3 minus 2 is +1. So we get 1 is equal to 1, which proves x does equal +1. So the answer to question number 2 is x is equal to 1.